in order for us to be able to effectively do Wi-Fi penetration testing, there are certain concepts about Wi-Fi that we need to understand. These have to do with the architecture of Wi-Fi networks and some of the protocols, fundamental protocols that are used in Wi-Fi systems. Firstly, let's take a look at some of the architecture concepts in Wi-Fi. There are two fundamental units of or groupings of devices in Wi-Fi, and one is the base service set. So with a base service set, that's where you you have devices communicating with each other over Wi-Fi, but they are not specifically connected to a larger infrastructure. Whereas what we see on the right side, we have the so-called extended service set. Here's where we might have multiple access points that are connected to each other through a distribution system, DSS distribution system, such as an Ethernet-based distribution system. However, it can even be a wireless or Wi-Fi distribution system. So you have multiple access points connected through a distribution system, and then there's a portal that connects all of this to an external network. So this is a more typical architecture that we'll see implemented for systems that use Wi-Fi. So you have multiple access points in a distribution system, and then with connecting through a portal to an external network like the internet. The mode with just a standalone base service set is also known as ad hoc mode. And the mode where you have this infrastructure and then connecting to the external network is known as infrastructure mode. So you can have multiple BSSs then linked by a distribution system into an extended service set, and that's the more common way that we see things set up. Now, I mentioned access points, right? So there's access points and then there's stations. So all these devices that you and I might be using, let's say with our laptop, our mobile phones, whatever, to connect through Wi-Fi to the internet, let's say. So we might be, let's say with our laptop here, we're trying to find a suitable access point. So we might be then scanning for access points that we can access, and then through that access point, then we get connectivity to the external network like the internet. So there are stations and there are access points. Access points are very similar to stations, except they have some additional functionality. So in terms of communications, though, the underlying communication protocols, MAC protocols, very similar, except access points have some additional capabilities that allow them to control the individual BSSs. And another thing that you might notice if you're just doing a simple scan around is that there's names as well. You'll see names, and these are the BSS IDs, so the base service set IDs, because each of these access points, then you have they would be related to a BSS, and then there'll be an ID. So BSS ID is something that you see. This would be the so-called names of the different Wi-Fi networks that you see around. And then sometimes you find that you cannot connect. In fact, most of the networks these days, you wouldn't just simply be able to connect if you just turn on your device and try and look for networks to connect through, because there's some security that's set up, and we will be talking more about these ways that security can be set up so that you can't just have a random person trying to connect through your access point to get connectivity to the network. By the way, this image here of the access point being another laptop, it's not that it's a wrong picture, but because theoretically an access point could be implemented in an access in a PC or laptop as well, not necessarily in some specialized hardware. And it's a good thing to know, because it's possible to go as part of penetration testing to go set up a fake access point, for example. We will be talking more about how control is done in Wi-Fi networks because there are certain vulnerabilities in the way that things are done, and so we need to understand how things are done, and then we can talk more about the security vulnerabilities and issues. So if you just imagine you have your device and you're trying to find a way to connect using Wi-Fi to the network. So you're going to see multiple Wi-Fi networks around. They're going to be on different frequency channels. Which frequency channel do we select? All right. So this is one of the things. Which Wi-Fi network to connect to, and then you need to select to then connect to the frequency channel related to that Wi-Fi network. Okay. But let's say you make a selection. Then there's a question about whether there's any access control for that Wi-Fi network. So there might be, you might need to know a web key. You might need to know some kind of pre-shared key for WPA2. And then actually, let's say you know the key and so on. So then what's actually happening in terms of the protocol, the signaling that's happening in order to get set up with this chosen access point. So there are certain procedures, and we'll talk about that. So you can associate with an ESS or BSS. And then if you're doing IP communications, there's the question about getting the MAC address for sending your IP packet. So what's the MAC address for the next hop? Let's say, for example, the MAC address of the access point, and or the other way around, the access point trying to get the MAC address for the device that you want to receive on, because it's trying to send an IP packet to you. What if we want to just what if we want to move away, or we're just using a different Wi-Fi network? What happens then? So these questions we'll get to in the next couple of videos. Continuing on with basic Wi-Fi concepts, we had previously asked these questions, and let's take a look at what you might find in a typical laptop. You might find some kind of helper tool like this, let's say on a Windows operating system, where it's looking around for the access points that it can see, and then it tries to connect. So in this case, well, okay, no, maybe not that many connections. So it sees one, and the signal strength is pretty strong. That's why you see about 80% here. If there's others that might be further away, then it might also show others. So people typically would then select one of these, and then your laptop Wi-Fi network interface card, or NIC, would then try to connect to that network. So what is happening when it's trying to connect to that network? What does it mean? So this issue about the multiple Wi-Fi networks around, what's actually happening is that in order to show you a GUI like what we saw in the previous slide, the network interface card is actually scanning through different frequencies to find the different Wi-Fi networks around. Now, depending on the capabilities of your network interface card, it might be scanning at 2.4 gigahertz, 5 gigahertz, or maybe both. And it's like tuning to an analog radio station. So you just scan through different frequencies. And what it's listening for is beacon signals that are being transmitted by the access points. So it's going to gather beacons signal information. It's going to then be able to know about the networks that are around. Now, the selection of the network, there can be different ways that it's implemented. So in the example that we saw here, the GUI is letting the user choose, and sometimes it might store the preferences so that the next time you turn on your laptop and try and look for a Wi-Fi network to connect to, it might automatically connect to something that you're previously successfully connected to before. So user might be presented with a choice, or it might try to be smart about it and automatically reconnect with something you had connected before. Now, just seeing these networks doesn't mean that you can connect to them. So after you select a network, there might be some access control that might prevent you from connecting to your selected network. That's where authentication is very important, because remember, this is wireless. So the access point is just receiving some signals over the air. It doesn't really know who you are. It's not like a wired network where there's cables connected to certain devices. So physically, there's this physical connection. So therefore, the network needs to do some kind of authentication. Various schemes are possible, and we'll talk about them. Some are much stronger, some are much weaker than others. In fact, the so-called open authentication is actually not doing any authentication. It's like letting everyone and anyone in. So after authentication, there's another concept about actually getting set up to talk to the access point. You need to associate with the BSS or the ESS, because the access point recognizes that you are authenticated as a particular user, but you still need to associate to the access point to this BSS or ESS. Associating is kind of like actually the analogy in the wired local area network is actually connecting this cable from your laptop or PC or whatever to the switch, and then you're able to physically get the packets to and from the to and from the destination and source. Now, typically, because we're talking about connecting to the internet, then there's another step that needs to happen after that, because in the process of authentication association, this is beneath the IP layer. So these things are happening without reference to a specific IP address. So it's just about at the layer 2 getting things set up. So then let's say you want to get IP packets to and from devices, then something needs to be done, and ARP is the solution, address resolution protocol. ARP we might already know from just wired LANs. It also can and does happen on Wi-Fi networks. So similarly, you need to have this mapping between IP address and MAC address that you transmit to. Now, when we then moved, let's say, to a new access point in the same network, so you're just moving within the ESS, then you can just reassociate. But because basically an ESS, as far as the IP network is concerned, an ESS looks like one big local area network. So you're not changing your IP address, so you're moving around within the same network. You just need to handle things at layer 2 to reassociate with the corresponding new access point. And then once you do that, you're good to continue with communications. And to then tear things down, you disassociate. And there's one more step that was not mentioned here, but you can also de-authenticate. So de-authenticate is like even more separation, because then the AP no longer recognizes you, meaning the station, as authenticated. So if you want to get set up again, you have to go from the beginning to authenticate again.